My name is Felix, and this is my submission for the CS109 challenge. I built a Bayesian network visualizer, and I think it's best if I go through one of the P-set homeworks to demo how it works.
Okay, so... Oh, I got TA feedback. Well played, but you unfortunately forgot to do the other part of the problem. Anyways, let's use that mistake as a way to demo my site. So here's the front page, and I have a graph editor, which I'll show later, tutorial, and a share function, which I will implement in the future. So there's 3 templates, but I'll just show Lime and Stealth Game Mission. So the homework asks for rejection sampling, and though there's exact sampling, I'll just show that later. Let's do simulation first. So let's select the states from the homework: tick, exposure, fever, and cough. Let's do 100,000 samples because that's the one in the solution. And if we run it, we can observe, if you hover, it's about 22%, and the one I forgot to calculate is about 79%. And here's the rest of the data here. You can hover to see all of it, but it's all here as well. And you can run the simulation multiple times to see the variance. You can compare it with 10,000 to see more of a fluctuation. Let's keep it at 100,000 because I want to compare it with exact. So if you look at these two, it's about the same as well, which shows that the rejection sampling is a pretty good approximation of the exact. Now let me show the other template. So let me just zoom out for this one because it's a bigger network. Just as an aside, here's some live graph customization features. So if you wanted to perform exact inference, this is actually blocked because of these reasons here. There's too many nodes, too many variables. It'll be too computationally complex. And that's why we have rejection sampling here. So I dealt with this firsthand, trying to perform exact inference, and the site just crashed. So that's why I put a hard block. So if you want to do simulation mode, I'm not sure if my CPT table is completely accurate, but let's try it out. So our probability of a mission success to be true is about 48%. Let's try and make it higher. So let's make movement speed high, player skills high. We see it's slightly increased. Let's leave no evidence. You can see it's slightly increasing. And I'd have to tinker with actually improving this model, but you can see that the node here is conditionally dependent on the nodes above. So yeah, now I'm going to show, finally, creating your own graph. So let's do consumed protein. Let's do went to gym and muscle growth. So let's connect consuming protein, going to the gym. Now I would assume that if you hadn't eaten your protein goals for the day, you're less likely to go to the gym. And the opposite is true for if you did eat your protein. Then let's connect going to the gym and muscle growth. So it's pretty self-explanatory that if you don't go to the gym, you're less likely to get muscle growth. So this is a pretty simple understanding of how muscle growth works, but it will suffice in showing how you can create your own graphs. So you can perform exact inference like before, clicking the nodes, and it will perform calculations here. You can do running simulation, and it will give you similar calculations as well. So the last thing I wanted to show was the dark mode, and having that option depending on when you do your homework, and the failsafe for if you want to make a cycled Bayesian network, because Bayesian networks must be acyclic.
So that's the end of the demo. And I wanted to mention some of the inspiration and reason for creating this. So a lot of it is inspired by 3-1 Brown and Obsidian's node map structure. And when I came across Bayesian networks in class, I was thinking it'd be pretty cool if there was a better way to visualize this and create your own networks using the infrastructure from Obsidian's app. And I thought, what if I used their infrastructure to create it, where it'd be visually pleasing to look at, similar to how 3-1 Brown makes it more intuitive to understand concepts. And the goal was to make something that didn't just tell you how it worked, but was visually pleasing to look at, intuitive, and incorporated the restrictions that real inference, general inference, has when you're trying to compute. And I remember in one of my old classes, I had to design logic circuits using computer software. And the software looked outdated, unintuitive, and it was just visually unappealing to look at. And I was thinking, this is one of the reasons why I wanted to make this site. Because it's very easy to overlook these concepts as just concepts, and rather something that you can play around with and create your own designs. And that way, it can seem like you actually are engaging with the concepts rather than just listening. And if I can make it more fun to create and look more beautiful, then that'll help with that. And I hope that I've achieved that with this site.